Hello students, in this session we are going to discuss quality control charts for range and for me. And for this what I'm doing, I'm considering an example of a teller who is working in a bank and quality control department is willing to observe the time that that particular teller is taking to resolve the problems of customers. So again we observe on 10 days the performance or the time that a teller takes to make the problem resolve of each customer. And let's assume that during 1 hour, after every 15 minutes, one customer is selected at random. So if the start time is 10 a.m., then the first customer is selected at 10 a.m., then the next one would be selected at 10:15, then the third one is at 10 for 30, and the fourth one is at 10:45. So four customers have been selected, let's assume. Now let's take this data as an example, that first customer on day 1 has taken 3.7 minutes, second customer 5.2, third customer 2.8, and the fourth customer, let's suppose it has taken 3.1 minutes. So what we do to compute range and mean, so to compute range we need to take the difference of the highest and the lowest value, that is 5.2, take away 2.8 gives us 2.4 minutes as the range of the time that the teller has taken in 1 hour with 4 customers. And as far as x bar is concerned, we need to add all the values and then divide this by 4, and this is giving us 3.7 minutes. So to save our time, what I'm doing, I'm ignoring these values and directly giving you the range and x bar values that you have presumably worked out, taking the range and taking the mean of these values. So let's suppose on day 2 that's 2.5 minutes, then 2.8 minutes, 3.2, 3.6, 2.5, 2.2, 2.8, 3.1, and 2.7 minutes. Similarly, 3.3, 2.9, 3.6, 2.2, 4.2, 3.8, 3.6, 2.9, and 2.5 minutes. Now what we do, we need to first define for the R chart the formula. Again, to get a unique value computed from this data of R, we need to compute R bar, and the formula is R bar plus minus, sorry, that's not plus minus, we can directly take the factor into consideration that's available in the factors for control charge. Therefore, there is no need to consider plus minus 3 times. That is already evaluated and incorporated in the factors for control charge table. R bar D3 gives you lower control limit, and R bar D4 gives you upper control limit. Similarly, for mean, this is LCL equals x double bar minus A2 times R bar, whereas upper control limit would be x double bar plus A2 times R bar. Over here, the factors or factor values D3, D4 and A2 we take from the control chart table. I'm going to show that. Let me check if it is available with me right now. Factors for control chart table is this one. Have a look on this. Sample size that we have taken each day is 4 customers we have selected. If we go to D3 factor, so D3 has no value, so it does indicate that lower control limit does not exist in case of R chart if the number of observations are up to 6. So it starts with 7th observation. Also, D4 factor value for 4 observations taken into consideration as a sample size each day is 2.8282. 2.282 is the value. Similarly, if we consider A2 factor for 4 observations, that has a value 0.729. So I'm going to write down these values. D3 value does not exist. D4 value is 2.282 and A2 value is 0.729. So we can now work out the lower control limit and upper control limit for R chart. LCL is equal to R bar times D3 and UCL is R bar times D4. So first of all, we need to compute R bar value, that is simply the mean of all values for R. So 2.4 plus 2.5 plus 2.8 plus 3.2 plus 3.6 plus 2.5 plus 2.2 plus 2.8 plus 3.1 and plus 2.7, and then divided by 10 gives you 2.78. 2.78 is the value of R bar. And if we go for X double bar, so 3.7 plus 3.3 plus 2.9 plus 3.6 plus 2.2 plus 4.2 plus 3.8 plus 3.6 plus 2.9 and plus 2.5. 32.7 is the sum divided by 10 gives you 3.27 as the value of x double bar. Double bar is the mean of the mean. Now it does not exist, so we need to not to consider, because D3 has no value for sample size of 4. D4 has a value, so 2.78, that's the R bar value multiplied by 2.282. So 2.78 multiplied by 2.282 gives us 6.34 as the upper control limit. Since lower control limit does not exist, so we can start drawing our graph from the minimum value available for range, and that's 2.4. So 2.4 is the minimum value that vertical axis should be labeled with. So the graph starting from 2.4 and it will go up to 6.34. So 2.4, then 2.6, 2.8, then 3.0, 3.2, 3.4, 3.6, 3.8, 4.0, 4.2, 4.6, 4.8 and 5, then 5.2, 5.4, 5.6, 5.8, 6, 6.2 and 6.4. So roughly over here we can draw the upper control limit at 6.34. The mean value is at 2.78. So 2.78 is over here. That's your R bar value, and the minimum value is at 2.4. Now these we will mark over here: 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, and we locate the positions of the range values each day accordingly. So 2.4, then we have 2.5, then we have 2.8, then 3.2, then on day 5 that's 3.6, then 2.5, fell down again, then 2.2, 2.2 rather was the minimum value, so that's 2.2, then 2.8, then 3.1, then 2.7, 2.8 as well, 2.8, then 3.1, and then 2.7. So this is how we do it, and we simply connect this. What we can do, we can draw the graph for X double bar chart in the same way. What we need to do, we need to work out, I am working out the lower control limit and upper control limit for this one. So lower control limit is X double bar, which is 3.27 minus A2 is 0.6 2.729 multiplied by R bar, which is 2.78, and UCL is 3.27 plus 0.729 and 2.78. So lower control limit is 3.27 minus 0.729 times 2.78. That's 1.24338. So we can take it as 1.24, and UCL we can take as 3.2 plus 0.729 times 2.78, 5.296. So this can be rounded off to 5.30. So this is upper control limit, and this is the lower control limit for X double bar values or X bar chart. So X lower control limit we start with, then we locate or graph or draw the line, solid line at X double bar value, which is 3.27, and then upper control limit, and then we can locate the days along the horizontal axis accordingly, and the values corresponding to each day, the value of X bar. And this is how we can spot two things, either of the two things or both, if we have a systematic error, systematic variation in the data, or we have a special cause variation. Again, if we have a look on this graph that we have drawn for R chart, we can easily see that there is no problem as far as systematic variation is concerned. None of the three values are repeated in the same order, as well as there is no special cause variation that we spot. Special cause variation can be spotted as when on a particular day the graph or the control chart crosses either the upper control limit or the lower control limit, or both. Okay, so that's all from this lecture.